Hello all and welcome back. So in this video, let's continue our discussion on recursion and solve one of the most famous problem in recursion, which is Tower of Hanoi. So first I will explain you the problem. Now again, this was given to you as an assignment as well. So I hope you have done the same your end at once. This is a little tricky to get, but once you actually apply recursion to it, you will realize the power of recursion, plus actually understand that how great recursion is, like how nicely it can solve question of these type as well. Okay. So great everyone, let me now try to explain you this problem. In Tower of Hanoi, what happened is that we have three towers in front of us. Okay, we have these three towers in front of us. Let's say this is source. Let me write on top of that. Let's say this is source. This is destination. And this is your auxiliary or extra auxiliary. Now our aim is to make sure that we are able to move these disks from source to destination using our auxiliary bar, okay, auxiliary tower. Now many of you might be thinking that why auxiliary tower is required, why can't I just put and just have these disks like this? Well, the problem with that is that there are some rules, okay, there are some rules. The rule says that A, you can only move one disk at a time. Second, nowhere in middle, okay, nowhere in middle should you have a case where a larger disk is on top of a smaller disk. So if you try to move the three disks the way you were asking without auxiliary, then there is no way to do that. Okay, there is no way, absolutely no way we can move them. Okay, so great. Let us now try to solve this. Before actually moving forward with solving, let me just show you some cases as well. We have to tell the exact path that let's say for example what we have to tell. If say this is going to be my S, this is going to be my D tower and this A tower, then I should basically tell, for example, for a single disk, if a single disk is there, I can just directly move from S to D. Okay, how I can do that? Let me showcase and visualize, help you visualize, as we are solving everything by visualization. So that would be helpful. See, this is the source one, this is the destination, this is the auxiliary. If I have to move a single disk, I can just pick it up and move it. Thus the answer is going to be A to B or source to destination. Okay. Now if I have to do the same thing for two disks, how it's gonna be? First I have to make sure that I move this one disk to C, then I can move this disk to B, and then finally this C. So first I'm making this disk move to auxiliary, so source to auxiliary, the first step. Second step, source to destination, and third step, auxiliary to destination. So the answer is going to be something like this: source to auxiliary, source to destination, auxiliary to destination. So anyone who sees this particular answer, he will be able to finally move the same. Okay, great everyone. So now let us move forward. We have seen two test cases, should be fine. Let me reset it. Okay, we have seen for 1 and 2. So great. Now many of you might be thinking that how are we going to go about the problem? How are we going to go about the problem? Well, we have to assume that, okay, see, the first thing is that we have to assume, so def Tower of Hanoi, okay, we will be getting n disk. You will be telling what the source is, what the destination is, and what the auxiliary is. Okay, like the name of these things. Let me just for the timing, because we are not printing anything, let me pass it. Tower of Hanoi, I am passing it for n disk. Okay, so let me take n is equals to something. Let us take 3 for the timing. N, source I am passing as S, destination as D, auxiliary as A. Okay, so these are just the names of my tower. Okay everyone, so I hope the problem is a lot clear. I have shown you, help you visualize the same. I have shown you using example as well. Now we have to just tell these paths for n number of disks, like this n can be any much. Now what exactly we have to do, let's understand the approach now. Okay, so we will have this thing, we will have these towers, right, and I have to assume for n disk. Now let us try to apply recursion for this, because I think this is a very recursive kind of a nature problem, right? We can handle some disk, some part, and recursion can help us do the same. this problem seems to be something which can be broken down. The very first is going to be the base case. Now I think we have already seen what base case can be. Like we can either have a 0, like we have the number of rings at 0, let's say, or the number of rings at 1, number of discs basically. So if it's going to be n0, then I can just return because I cannot print anything. If n is equals to 1, then I have to make sure that I'm moving my disk from source to destination, and I will get my answer, right? So if I make it 1, then all I have to do is move from source to destination. Okay, for the timing, let me make it source destination so that you don't get confused and you have a proper answer, and auxiliary. Great, cool. So now let us see how recursion can help us do that. Now my whole understanding with recursion is that I'm going to do some work and I'm going to ask my recursion to do other work for me, right? These are your base cases, everyone. Now second one is your recursive call. Right? Now what I'm actually thinking of, is that, see, I have this particular fixture. Right? So pay attention what I'm going to do, everyone. This is going to be a little bit different on the questions we have done. Let's say I have n disk here. Now what I'm going to do is, this is source, this is destination, and this is auxiliary. What I'm going to do is, I'm going to ask my recursion that, hey, you take care of this n-1 disk, and I'm going to take care of this one disk. Because it makes sense, right? We are lazy, we want to do less work. So I will ask my recursion that, hey, can you somehow do something for me? I know that we have to move these disks, we have to move all of these disks to destination here. But can you, for the timing, please move all these n-1 disks to this particular extra tower or auxiliary tower instead of destination. Now why am I asking recursion to do it? The reason is that if recursion is able to make all of these disks here, then I will be just left with one disk, and I know I can move this one disk easily from here to here to the destination, right? So I will explain this again because this might become a little tricky. So pay attention, everyone. What I'm going to ask recursion to do is, these are going to be my n disk. This is going to be my source, destination, and auxiliary. For the time being, I will ask my recursion that, hey, can you move these n-1 disk from source to auxiliary such that my auxiliary will have these n-1 disk, right? Now once recursion has moved the same, I will just be left with this one disk. This one single disk. Now this single disk, to move from source to destination, it is very easy. I can just directly move from source to destination. That is how we handle single disk, right, everyone? And if you have done this, now once I move this single disk as well, here, then what can I ask my recursion to do is that, hey, now you don't have to do anything, just move all these n-1 disks, assume that this is source, destination is this only, and you can take this source tower, the initial source tower, as an extra or auxiliary one. So use this tower and move everything to D, to the destination. Okay, I hope this is clear. I will repeat it one more time so that it becomes a more clear, and just another analogy. So pay attention, everyone. Let's say you have n disk here. Okay. For the time being, this is your source, this is your destination, this is your auxiliary. Now let's say I ask that, hey, instead of destination, move everything to auxiliary. I think you can do that easily. You don't have any problem in that. This destination and auxiliary both are an empty tower for us as of now. So all I'm saying is that, hey, move this n disk directly to auxiliary using destination. I think you can do that. Should be fine. Great. Now let's say I had a disk here as well, which was inside the ground. This was a n+1th disk, which was inside the ground. Now, of course, I have to handle the same as well, right? This is the n plus 1th disk. So all I'm saying is, imagine with respect to n, because I know that n minus 1 might be a little difficult. The good thing that I've taught you PMI. So there we used to take for k plus 1 and k exactly, right? So let's say you are doing it for n, and then I found that, okay, hey, there is another disk here. What should I do to it? What exactly should be done is, I can move this particular disk here easily, right, to destination. Moving a single disk from source to destination is easy for me. When I will do this, nothing has actually changed. This is still the largest disk. I can put anything on top of it. I don't have any worry. I have just moved a single disk. So all the rules I have made sure that I'm following. Now, because you will have all of these n disk here, and I will just draw it again once more. Now, because on your auxiliary, all the n disks are there. These n disks are on auxiliary. What you have to do is, now again, and it should not bother you that destination is having this big disk, because it's anyway an bigger disk, so you don't have to worry, because you can put anything on top of it, right? The condition is that bigger disk cannot be on top of smaller disk, not the vice versa. So now I am just saying that, hey, move this n disk, assume this is the source and this is the auxiliary, and move from source to destination. Okay, just this is the understanding. Now I hope this is a lot clear, everyone. Okay, so now let me write the code and it will become more clear. So all I'm asking my recursion to do is, that, hey, take these n minus 1 disk, move them from source, to auxiliary, but use destination as your auxiliary. So this time source will go to source, auxiliary will be the destination, and destination is going to be the auxiliary. So this is some smart thing which I'm doing. Once this has been done, I know that all these n disks have been moved to this particular tower. Now I found one extra disk. What I have to do for that, I know. I can just print this actually, source to destination, because I can move my disk. And now all I have to do is I have to ask recursion that, hey recursion, can you please make sure that all the disks which you kept on auxiliary, please move them to destination and use source tower as an extra tower. And actually this is done. Like, this is all you have to do. Okay, just let me correct the indentation, because all this is inside. Yeah. And now this whole thing is done actually. So I can test it out as well. See, source to destination, right? Okay, 1 second. How is it 2 times? Okay, I'm doing pass. I have to return it. Great. For 2, source to auxiliary, source to destination, auxiliary to destination. This is what we saw here as well, right? For 2. Now let us see for 3. What I'm going to do is I'm going to just check the count, because it's going to be a lot high. 7 is the steps. So let us run for 3. It's saying the number of moves for 3 disks is 7. Okay. Let us do it for 4. Let us just check the steps. Okay. It's 7. Oh, sorry, my bad. We have to increase it. It's 15, right? So for 4, it's going to be 15. What I can do to check it? Maybe I can have some step is equals to 1 initially. I can just print step as well. Okay, so this will help us count easily. Great. And whenever I'm doing this, I have to make sure that step should be plus equals to 1. When I'm doing this, step should be plus equals 1. Yeah, now it should work fine. What's it saying? Okay, my bad. Global step. So scope of variables, we have already learned about them. See, 15 steps are there, right everyone? So I hope you are able to understand what exactly happened here. You are able to understand what exactly happened. Let me just remove this. By default separator is there, so I don't need this. See, 15 steps are there. Now I can run for 5 as well. Now one thing is there, it's a very heavy problem, like for I think some use case of 50 or something, it will take forever to run. Okay, so there are 31 steps, and this is going to be right. Again, please make sure that you understand the intuition. here we are making two of these recursive call. We have asked recursion to do our work in a different way. That's why two calls are there. Okay, we are dependent on recursion two times this time. So this is a very famous problem which we solve using recursion. So that's why I made sure that I discussed this. This should have made your horizon a lot more clear on recursion, that how exactly it can be used. So yeah, I think that should help. Please make sure that you understand the same. Let me just same thing, right? 1 second. Great. Okay. Cool, everyone. So I hope this was clear. Please make sure that you see it once again if it is not. It is a little bit tricky, but I've made sure that I'm explaining you with the best visualization and steps possible by even connecting it with PMI and taking for n+1 as well. So try to write your code once again yourself, okay, without referring to this code which I have written. And let us meet in the next video. Thank you.